Okay, I'm picking up here where I left off, number 23 on 10.4. So now I'm going to pick up and do 27. So on 27, find the area of the parallelogram with these vertices. So we're given points, -2, 1. B is 0, 4. C is the point 4, 2. And D is 2, -1. So imagine in two-dimensional space, point -2, 1, it's A, 0, 4, 2, 3, 4, here's 4, 0, 4, that's B, 4, 2, 1, 2, 3, 4, 2, that's C, and 2, -1. So we want the area of that parallelogram. So what we need to do is, they're telling us it's a parallelogram, so we can trust that. All we need to do is come up with two vectors, which I could do this vector from A to B, and I could do this vector from A to D. And all I have to do is look at the magnitude of the cross product, and that will give me the area. So let's first figure out the vector from A to B. So from A to B, we did this already. We do 0 take away -2 is 2. 4 take away 1 is 3. Cross that with the vector from A to D, so 2 take away -2 is 4. And then -1 take away 1 is -2. Like that. And here's the problem we run into. Our cross product is only defined for three-dimensional vectors. And because of that, we're sitting here in two-dimensional space and we're like, well, wait a minute, hold on, how are we going to do a cross product? Well, this is where we have to extend our points into three-dimensional space. So what we're going to do is we're just going to imagine that these are all sitting in 3D now, but they all have a 0 coordinate for the Z. So let's say this is X and this is Y. Z comes out at us. We're just saying these are all laying on the ground. It's all Z equals 0. So what that allows us to do in this cross product is change this to 0, cross, and then over here, 0. All right, and we'll take the magnitude of that. So we've extended our two-dimensional picture into three-dimensional space so that we can define the cross product. And now we just need to take the cross product and then take the magnitude. So for this cross product, I'm going to write them vertically, so it'll be easier for me to do a cross product. For -2, 0. So if I'm going to get the I part, I cover up the I and I do my little determinant. So 0, 0, so I get 0 for this piece. And then I cover up this, 0, 0 again, so 0. And then I cover up this piece. I've got -2 times 2, so -4, and then I subtract from that 4 times 3, which is 12. That's going to give me -16. And then I want the magnitude of this, right? The magnitude of the cross product. And that's just going to be the square root of the squared plus the squared. So it's basically going to be the square root of 16 squared, which is 16. So that should be the area of the parallelogram formed by those 4 points. Oh, come on. Okay, that's it. All right, number 28 can be done the same way as the last one. We don't need to draw it, except that those points are already given to you in three-dimensional space. On this problem, this is number 29. We're given 3 points, and I went ahead and plotted these points. It's the point 1, 0, 1, which is here, that's P. Q, which is negative 2, 1, 3, there's Q. And then R, which is 4, 2, and then 5. And so what we have is these 3 points, okay, these 3 points create a triangle, and that triangle lives in a plane. And I'm trying to find a vector that's perpendicular to the triangle or perpendicular to this plane. And so what I can do is I can create 2 vectors out of the triangle, take their cross product, and we already know that when you take the cross product of 2 vectors, the resulting vector is orthogonal to both vectors, which means it's orthogonal to the plane. So I've already got the points listed here. I just need, what we need to find is the vector PR and cross it with the vector PQ. So let's do PR. PR is the vector from here to here, so 4 take away 1 is 3, 2 take away 0 is 2, 5 take away 1 is 4. Okay, that's PR. And then I need to cross it with PQ, so I'll put PQ here. So PQ goes from P to Q, so negative 2 minus 1 is negative 3. 1 take away 0 is 1. 3 take away 1 is 2. So now I need to cross these 2 vectors. So to find the I part, cover this up. Okay, and this will be 4 take away 4 is 0. Okay, to find the J part, cover up J. 3 times 2 is 6, so 6. Take away negative 3 times 4 is negative 12, so that's going to give me 18. But then I'm subtracting it because it's the middle one, so minus 18. And then the last one, I cover up this, and I've got 3 take away negative 6, so 3 take away negative 6, that's going to be 9. So this vector is orthogonal to that plane. In fact, any multiple of this. So you could like divide it by 2, divide it by 9. That would work. You could multiply it, you could take this and multiply it by negative 1. That would work. So any scalar multiple of that vector would be perpendicular to that plane. So that's part A. Part B, it says find the area of the triangle. So this is kind of interesting. If we look at, there was the cross product, right? Remembering that this triangle is formed by 2 vectors, right? And then there's that third side, which is this one. We know that we can find the area of this parallelogram by taking the magnitude of that vector. So the area of the triangle is half of it. So all I need to do is take half of the magnitude of that vector. So let's do that right here. 1/2 times the square root of 0 plus negative 18 squared plus 9 squared. And this would be, I'm just going to do it on the calculator, get the answer. Square root of 405, and then half of that. So half of the square root of 405. Whatever that is, get a decimal, doesn't matter. Okay, that's 29. 30. Let's see what else I have on here. 30 and 31 will work the same way, so I won't do those. And then 35 is the next problem. So for 35, 35. You have find the volume of the parallelepiped with edges PQ, PR, PS. So they give you some points. P is negative 210. Q is 232. R is 1, 4, negative 1. And S is 3, 6, 1. So we have 4 points sitting out in space. All right, so let me see. PQ, PR, PS. So we have, let's say, P. Okay. We have Q. We have R. Let's start with that. So they say that the edges are PQ, PR, PS. So PQ is this from here to here. PR is here to here. And then this other point we have, S. I don't know where I want to put it. Let's put it here. S goes from here to here. Wow, so it's really hard to see what's going on here. But imagine having arrows like this. So, boy, it's hard to draw this. Let's see, I've got about as good as I'm going to get it. Okay, so we have a parallelepiped. Let me try and do it with a visual. We have a vector. Forget that picture. We have this, and a third vector like this. Okay, and so we have 3 vectors. So P was here. We have, P to Q. Let's say P to Q, P to R, which is P to R, and then P to S, which is here. So 3 vectors. And those vectors form a 3D parallelepiped. You can check in your notes. I show this in our notes. You can turn it around and stuff. But what we want is the volume of that. So we're just going to use the formula, all right, which is the magnitude of the triple scalar product. So let's call a couple of things. Let's call this vector A, this vector B, and this vector C. So let's find out what those are first, and then we'll use the formula. So A is the vector from P to Q. So P to Q. So 2 take away negative 2 is 4. 3 take away 1 is 2. 2 take away 0 is 0. So there's A. I need vector B, which is the vector from P to R. So P to R. So 1 take away negative 2 is 3. And then 4 take away 1 is 3. And then negative 1 take away 0 is negative 1. One more vector, C. And it's the vector from P to S. So from P to S. 3 take away negative 2 is 5. 6 take away 1 is 5. And then 1 take away 0 is 1. So the formula for this, the volume, is the magnitude of A dot with B cross C. So I'll get rid of my picture. All right, so let me find B cross C first. So I'm going to cross these two together, okay? These two, I'm going to cross them. So B cross C is equal to, so we want to get the I component, we cover up I, we get 3, take away negative 5, that's 3 plus 5, that's 8. And then we want to get the J, so we cover this up, we get 3, 3 take away negative 5, again, that's going to be 8, but then it's minus, so negative 8. And then to get the last one, it's 15 take away 15, it's 0. So I got 0 here. And then I want to dot that with A, which was 4, 2, 0. So the dot product's a lot easier. 4 times 8, right, is 32. So this is going to be absolute value of 32 plus, let's see, negative 16, and then 0. So that's just 16. So the volume of that parallelepiped is 16 units. What number was that? That was 33. Did I do 33? You know what? I think oh, that was 35. That's why I'm sitting there going, what the hell? You know, I forgot to do number 33. Was that not on your homework? 33. Damn it. Well, 33 is easier than 35. 35, yeah, that's right. Okay, so this is the right answer. But on 33, they give you the 3 vectors to start with. So you don't have to get these. So that'll be pretty straightforward. The answer to 33, you should get 9. Okay, 37, last one. Use the triple product to verify that these vectors are coplanar. Okay, so let me try and explain what's going on here. And you write down these vectors I give you. U is equal to the vector. I'm going to switch it over to the other form. 1, 5, negative 2. V is the vector 3, negative 1, 0, since it doesn't have a k-hat. And W is 5, 9, negative 4. All right, so here's what they're trying to get us to see here. We have 3 vectors. So there's a vector, here's a vector, here's 3 vectors, okay? Let's say U, V, and W. And when we take these vectors and we put them all tail to tail to tail, what we want to show is that these 3 vectors are coplanar, which means that, let's say we take 2 vectors, just 2. I can take these 2, I can twist them to make them fall into one plane. And what I want to show is that this 3rd vector has to also lie in that plane. It's flat, that it can't be coming out. If it comes out, think about it this way, if it comes out like this, then if we try and find the volume of this, we should get a number, positive number. But if they all lie in the same plane, then this shouldn't have any volume to it, right? Because they're all in the same plane. We need one of them to pop out in order for us to get some sort of volume. So what I want to show here, right? I want to show that the volume is equal to 0. So I want to show that the absolute value of, now I'm not going to use ABC, but I'm using the triple product here. U dotted with V crossed with W. I want to show that that is 0. If I can show that, then they must all live in the same plane. So we need to cross, let's cross V and W. So V crossed with W is equal to, let's see, cover up the I. We've got 4, take away 0 is 4. And then cover up the J. We've got negative 12, take away 0, but then change it, so 12. And then this one right here, we got 27, take away negative 5 is 32. 32. Okay, now what I want to do is I want to take that and I want to dot that with U. So U was up there, 1, 5, negative 2. So let's go ahead and dot these together. If we dot, then what do we get? We get 4 plus, let's see, 50, that's 60. And then here, multiply, we get negative 64. And that is 0. And so it checks. All right, that is all the homework that I have assigned for 10.4. All right, sorry. Shoot, man. No. You know what? Man, I am just all over the place today. I did 37, didn't even assign 37. I need to do 39, 40, and 41. I did more problems than I had to. And that's okay. 39, 40, and 41. Those are all word problems. Let me do 40. I think I've got about 10 minutes. I think I can do this. Let me try and do 40. $39 and $41 I'll leave to you because those are both odds and word problems. So I'm kind of leaving these problems at the end for you to kind of explore on your own. I don't want to give everything away here. All right, so it gives a picture, it gives a point P, and then it gives 4 feet, and then this looks like a right angle straight down, another 4 feet, and then it gives a flat line here, and then it tells you that you've got this vector. This is 30 degrees, and this is 36 pounds. That's it. So the question is, find the magnitude of the torque about the point P if 36 pounds of force is applied as shown. So what they want is that, you have this metal L here, and you're grabbing this point and you're pulling on it 30 degrees to this line. You're pulling on it with a force of 36 pounds. What is the torque about this point P? So all we need to do here is extend a vector that comes across like this. Okay? And we're going to be using the fact that the torque, okay, your torque vector is equal to your R crossed with F. So R is this vector here, and F is this vector here, force. All right, so do they want the actual, what do they want? They want the magnitude, right? Because they're not wanting the torque vector. They want the magnitude of the force. Let me just find the magnitude of the torque, yes. So they want the magnitude of the torque, which is the magnitude of the cross product, which is much easier to calculate because this is just the magnitude of R times the magnitude of F times sine of the angle between the vectors. Okay, so we got some work to do here. We need to find how long this is. We already know the length of F because the length of F is this force, so the length of F is 36. We need to find the length of R, and then we need to find the angle between the two vectors. Now that's going to be a little bit tricky. All right, so finding this length is going to be pretty easy. This is a right triangle, so Pythagorean, a squared plus b squared is c squared. So 16 plus 16 is 32, so this is root 32. And yeah, that's it. So I'm going to write some stuff down here. I'm going to draw another picture. Remember, that's what we want to calculate. We have this one vector. It's coming down like this. This is 45 degrees. We know that. The length of this thing is root 32. Okay, the length of R is root 32. And then we have this other vector, which is, I'm going to move this tail to tail right here, move it up here, so it looks like this. This is our force vector. and it has a length of 36. And so what we need to know is the angle between the two vectors, theta. We know this is 30 degrees. We know that's 45, so 30 and 45, that's what, 75? So this angle adds up together to be 180, so this is 105 degrees. So now what we'll do is we'll take the magnitude of r, which is root 32, times the magnitude of f, which was 36, and then sine of 105 degrees. And I believe I'll need my calculator for that. Let me see here. So this is approximately 197. This is approximately 197, and then the units, because this was in pounds and feet, this is going to be foot-pounds. So that is the torque that we have on that point P, 197 foot-pounds. Hope that makes sense. That'll do it. I think that'll wrap it up for this section.